We'll proceed in vector summation and integral calculus. Okay, so aim is to solve a problem. Aim is to solve a problem. In solving the problem, we are using a technology called breaking problem into n part, that is also called breaking problem into n part and then sum it. Then solving one part. If I have a big problem, I cut the problem into n part and then each part I solve it and then at the end I sum it. While solving each part, why I need vector. Okay. Prior to that, we are in discussion for the parameterization. Parameterization in a vector. If I am using vector to solve each part, one part, if I need a vector to solve it, then why we need parameterization? Parameterization is delegating the problem into different orthogonal systems. Okay, like we have given example, like if I'm trying to find area or circumference of a circle. If this is a circle, I'm trying to find area or circumference. Circle can be centered here. Circle can be centered here. Okay, circle can be centered here. Here is the center. This is the circle. Or circle can be centered here. What is your problem? I'll tell what is my problem. Okay, circle can be centered here. Up, up, up. Circle can be centered at the middle, or circle can be centered here. Circle can be centered here. Circle can be centered here. Up, up. Center means origin. Up, up, up. I'm sorry. Circle can be centered. The center of circle is where? Okay. Is it coinciding the origin? Yes, it is coinciding the origin. It is coinciding the origin? No. Center of the circle is here and origin is here. Center of the circle is here, whereas origin is here. Center of the circle is here, where origin is here. Okay, this is called a drawing a circle with different. This is called drawing a circle with different kind of displacing the center. Okay, how to find area of the circle? Very simple. You get the radius. It is after all, it is a circle, right? Only it is displaced here and there. That's it. Get the radius of the circle and then pi r square. How you get pi r square? I don't. How I get pi r square? I don't know. But this is how it is. How? What is circumference of the circle? You know the radius, right? 2 pi r. How we get 2 pi r? I don't know. Okay. Then we are thinking. Then okay. Okay. Tell me what is the area of a rectangle? What is the area of a rectangle? Then width by height. If you see rectangle, width into height is area of rectangle. What is the circumference of a rectangle? Then width plus height. Width plus height multiplied by 2, or width plus width plus height. That is the circumference of a rectangle. What is circumference of a circle? Okay, height, okay, height, sorry, width, height. What is area of a circle? Height into width. But this is not, it will work in Cartesian coordinate system. This will not work in Cartesian coordinate system because it is not a flat line. It should be parallel to the x-axis and parallel to the y-axis to say it is. Okay, we have talked about it many times. This is called pseudocode. I can write pseudocode. What is the height of the circle multiplied by the width? This is the area of any curve. What is the area of a rectangle? Height by width. Area of rectangle. Height is y, width is x, or height y I can say function over x, which is constant, a parallel line. Means if this is the x-axis, then every moment of x I have a constant height. Height is constant every moment. If I connect all the constant point on the top, then it will be a flat line. This flat line and this perpendicular and this forms a rectangle. What is area of the rectangle? Height by width. If this height is y, I can say function over x because at every moment x, I have a vertical. Function over x into x is the area of rectangle. Makes sense? What is area of the circle? Then I can write same thing. Function over x into x, where function over x is changeable at different x, at different x, the height is different. See, function over x into x is the area. Where it is area? Show me. Yeah, this is the area. I have seen in written in the book that area of any 2D shape in Cartesian coordinate system is or for rectangle. It is function over x into x. Then it should be same for a circle, should be. But it is not the case. Function over x is variable. And what is function over x? It is square root of a square minus x square, where a is the radius of the circle. Square root of a square minus x square. That is the equation of the function over x into x will give the area. Certainly it will not give the area. Then we go with the integral calculus. We change x into dx, then it will give the area. Function over x into dx, height by width. Height is function over x and width is, instead of saying x, I write as dx. People say dx means delta x. Delta x means at any moment x, if the height is fx, then this is delta x. What is delta x? Chop x axis into n different parts where n tends to infinity, and each part has a width of delta x. At this x, what is the height multiplied by delta x? This is one sub area. Add all the sub area, you get the fx dx. Fx dx integration fx dx is same as summation I equal to 1 to n fx. X belongs to the ith section. Delta xi, same thing. N tends to infinity. Okay, okay. Which is first? If I take the small subsection, I divide x-axis into n different parts and take one part, any ith part, and calculate the area, function over x multiplied by delta x, and then generalize it for all I and add it, then it is same as fx dx. So integration means I divide x-axis into n part, n tends to infinity, and each subsection I take the width at delta x, and there at any point in this section, any point, middle point, right point, left point, any point, or I can take 3 point and average of it, whatever. Take the height, that is fx in the ith section. This is the first section, second section, ith section, nth section. Fx in the ith section into delta x. Now sum it for all the sections. Sigma I equal to 1 to n, n tends to infinity. Fx, x in the ith section, delta xi. This will give the full area. That is the fx dx. So integration started from this uh, addition of the sub area. Who is first? This is first. Integration fx dx is the area, not that is the first. Breaking into that, we understand in that fashion. Integration has nothing to do with dividing into n different part and each part sub area, calculate and then add it, it will become integration. That is not true. Integration did not start from dividing any problem into n different parts and calculate the area of each sub part and then add it and make n tends to infinity. Then you will come to this is not the breakup. This someone can understand through that manner also. But integration has nothing to do with dividing into n part. Integration is completely different thing. Okay, anyway, right now we will go that our area is nothing but fx dx. X is the base and height is fx. Rather than directly multiplying it fx with x, I put d there, making sure that it is integral calculus. It is not direct multiplication. If someone is writing fx into x is the area, then he will try multiplying directly. Well, fx is the square root of a square minus x square for circle into x. So that will become x into a square root of a square minus x square. That is the area of the circle. That is not true. Someone has that to discriminate it. Someone put fx into dx. D for the integration. You have to integrate it. Okay. Then people started thinking that d means delta. D means delta. Fx in the ith section into delta of the xi, and then do summation I equal to 1. This is another way to understand it. but it is not the same. Integration is completely different. Okay, someone can break, someone can say dx and delta x, it is up to him. But it is not like that. If someone think in that fashion, then after some time he will start hitting the wall because that is not the truth. Anyway, this is not Sir Isaac Newton would have thought about it. He thought from different perspective. Under primitive calculus video, we have uploaded a series of video under primitive calculus. There we have talked about the how calculus started and then what is concept of dx. Certainly it is not delta x, but we can understand in that fashion also. Anyway, we are in phase of using vector and parameterization in calculating. Parameterization means this invention of different coordinate system. That is parameterization. If I'm trying to calculate the area of a circle or circumference of a circle in xy coordinate. In xy coordinate, the curve is like this. What is the area? What is the circumference? Okay, then we came to know that there can be another orthogonal system that is hiding here that we are not seeing it. X-axis and y-axis it is viewable. I can see x-axis and its perpendicular is y-axis. That I can see. Okay, but there is another coordinate system that is hidden here that I cannot see. What is that coordinate system? That coordinate system is if I connect origin. Okay, luckily origin and the center of the circle is same. Luckily, but it may not be the case. Now, if this is the origin and center of the circle, from origin I connect a point here, and then this is called radius, and radius is moving like this, and radius make 360 degree completely, and then it forms a circle where radius length is not changing, but radius direction is changing. That is called theta. Okay. Now, if I take instead of this angle theta, the angle, this is the angle theta, this is the angle theta. This is the angle theta. This is the radius. Theta is changing. Radius length is same. Okay. In that fashion, it forms 360 degree and it forms a circle. If I take the circumference, if I take the circumference, which is changing, right now circumference is 0. Circumference is growing. Circumference is growing like this. Okay, so if I take the circumference, then circumference denotes the angle theta and r. If I multiply this r with angle theta, it becomes r theta, that is the circumference. Means more or less what is visible to the eye as far as the another coordinate system is, one is radius and one is circumference. These are the two lengthy thing that is visible to one, and then they are at 90 degree to each other. This radius at any point, if I see the line direction, what is the direction of the line? Here, if I this is x-axis, okay, if this is x-axis, then what is direction of the line when y equal to 0? It is round, not true. This is what we are saying. What is the direction of the circle at x equal to a, that is the radius of the circle, and y equal to 0? At this point, what is the direction of this line? Line is changing its direction somehow. What is the direction of a line along this line? Everywhere same, along the x-axis. Any point you take, the direction will be x-axis only. What is direction of the line when I talk about the circle? At this point, direction of the line at this point is exactly vertical. Exactly vertical. No, it is round. See, it is making round. See, it is making round. I have given this example. Moon looks round. Moon looks round. But if someone go near to the moon after some time, I believe below 100 kilometer or 50 kilometer, moon will start looking flat. If someone stands on the moon, he will say, "Who is saying moon is round? Moon is completely flat. Moon is not round. You have to see from the far. If I see from the far, it looks like circle. This line is turning like this. But if I go and see from, this is called local linearity. If I if I see from the local, either I put my eye exactly close to that point, it will look linear, straight line. And what direction the straight line? It is exactly vertical. What is the line direction of the line passing at this point? This direction. This direction. This is also referred as tangent line. Okay, so radius is always perpendicular to any point on the circumference, the tangent line, always perpendicular, always. Okay, if there are two things I have discovered that are 90 degree to each other and they can represent a curved line. If I just say, can you represent a curved line in XY plane? Can you represent a curved line in XY plane? I mean, circular line in XY plane. Yes, I can represent. Who said I cannot represent? X square plus y square equal to a square. Okay, if center is keep on changing here and there, you can put offset the way it is. If center of the circle is at 0 comma 1 by 2, center of the circle is at 0 comma 1 by 2, where radius is 1 by 2, x square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. Wherever the center is going, that offset you have to decrease in x and y accordingly. Okay, I represent the circle in Cartesian coordinate system. Can you represent the circle in some other coordinate? You're talking about some other coordinate system. Yeah, what is that? That is radius and arc. Arc is a representation r into theta, where r is constant and theta is variable. More or less, I am talking about r and theta are the two entities in Cartesian coordinate system. I have found miraculously that also denotes a orthogonal system. Orthogonal system means arc and radius are perpendicular to each other. The way x and y are perpendicular to you. I have found something new. If it is a coordinate system, then you can describe circle through coordinate system also. Yeah, I can describe circle through coordinate system. What is the coordinate system then? R equal to a. R is always constant a, and theta is going through 0 to 2 pi. Okay, what do you mean? R equal to a. That is the set. I found one coordinate system where equation of the coordinate system is r equal to a, irrespective of theta. Theta is the angle irrespective of theta. Theta is 0 to 2 pi, where theta is 0 to 2 pi. Okay, what is another thing that you have found? Consider the circle is center origin of this xy coordinate system is here, and this is the circle. What is the equation of the circle if radius is 1 by 2? X square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. Now tell me in your r and theta, then it is r equal to sine theta. How you found out r equal to sine theta? What about this? R equal to cos theta. What about this? You have to, how you are finding out r equal to cos theta sine theta? Okay, what is your equation in Cartesian coordinate system? X square plus y square equal to x square plus y square equal to a square. A square is the radius of the circle. Okay, now substitute x and r cos theta. What is that? Okay, this is in our concept, radius is a guide. That one end of the radius is origin 0 comma 0, or other end is along the circumference. This is radius. Means if I talk about this is radius, then this is angle. R cos theta is x and r sin theta is y. Just substitute there. X square plus y square equal to a square, you said, right? Or x square plus y square equal to 1 by 2 whole square. That is the equation of a circle centered at the origin. Replace x with the r cos theta and y with the r sin theta. Now we don't have any x and y, right? Yeah. R square cos square theta plus r square sin square theta equal to 1 by 2 whole square. Means r square equal to 1 by 2 whole square. R equal to 1 by 2. That is the equation of circle in the polar coordinate system. R equal to 1 by 2. Okay, tell me another thing. X square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. I have a shifted circle now. Place it, same thing. R equal to x equal to r cos r square cos square theta plus y minus 1 by 2 whole square. R square sin square x equal to the equation of the shifted circle is x square plus y minus 1 by 2 whole square equal to a square equal to 1 by 2 whole square. X equal to r cos theta, y equal to r sin theta. It is r square cos square theta plus r square sin square theta plus 1 by 2 whole square plus minus r sin theta equal to 1 by 2 whole square. It will become r equal to sin theta. What about a circle that is shifted here? Equation of the circle in r and theta. Then it is x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. X minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. Okay, in that fashion, it will become, someone can substitute x square r square cos square theta plus 1 by 2 whole square minus r cos theta equal to r square sin square theta equal to 1 by 2 whole square. It will become r square. It will become r equal to cos theta. What about a circle? Circle that is like this. That is x, so like this. That is x minus 1 by 2 whole square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. It is shifted. X is shifted 1 by 2, y is shifted 1 by 2. Okay, in that fashion, r cos theta minus 1 by 2 whole square plus r sin theta minus 1 by 2 whole square equal to 1 by 2 whole square. Someone can settle down. It will be little complex. R square cos square theta plus 1 by 2 whole square minus r cos theta plus r square sin square theta plus 1 by 2 whole square minus r sin theta equal to 1 by 2 whole square. It will cut down and then it will become r square minus r sin theta minus r cos theta plus 1 by 2 whole square equal to 0. Okay, it will be complex, but this is the equation of the circle in r and theta. Okay, you have discovered something. Okay, we can represent any circle in the form of r and theta in Cartesian coordinate system. What is your new coordinate system? It is called polar coordinate system. This is an invention. Polar coordinate system. Polar coordinate system. Now, what is the advantage of the polar? First of all, this is called parameterization. I have x and y. Earlier we have y dependent upon x. In the formula of x axis and y axis, y is dependent upon x. Y is fx, function over x. Now in new formula, we have x and y both are dependent upon theta and r. X equal to r cos theta, y equal to r sin theta. Okay, we have new thing discovered which is independent. Theta and r are independent and x, y are dependent upon them. This is called parameterization. Now whatever we were representing through x and y, same thing I can represent into r and theta. If r is constant, then only in theta. This is called parametric vector. Any point here in the circle, I can describe as point x comma y, or as a position vector xi plus yj. Xi plus yj I can rewrite as r cos theta I plus r sin theta j. If r is constant, I can take it out. Cos theta I plus sin theta j. If theta is somewhere else in the universe and I have xy plane, just tweaking the theta, you can tweak the full circle. Now your handle of your problem went to some third party theta. This is called parameterization. If I am going to show something as third party, I can solve big problem. It is not that simple the people are thinking. Okay, what is? You could have solved in the xy plane itself. Why you invented something called theta that is not here, somewhere else? That is required, that we will see. Importance of parameterization vector in solving any problem, and then importance of the vector. But what is good thing about here is, what is the default shape of circle? What is default shape of the circle? Default shape of the What is default shape of a Cartesian coordinate system? Then it is rectangle. That is called default shape of Cartesian coordinate system. If I have a Cartesian coordinate system, okay, if I have a Cartesian coordinate system, if I have a this is Cartesian coordinate system. This is x-axis and this is y-axis. This is Cartesian coordinate system. What is the default shape for there? For any coordinate system, there is something called default shape. If this is Cartesian coordinate system, what is default shape? Default shape means a line that is parallel to both the axes. If I take line parallel to this axis, then it will be this line. Parallel to this axis, this line. It forms a rectangle. Rectangle is the default shape for Cartesian coordinate system. If I have a hybrid, if I have a polar coordinate system inside the Cartesian coordinate system, then this is the radius and this means y-axis I can change it to radius. This is radius and this is angle. When radius is moving like this, it forms a curve. This what is the default shape of polar coordinate system inside Cartesian coordinate system? Circle. Circle is the default shape of polar coordinate system. Default shape means if what is the area of the rectangle in Cartesian coordinate system? X-axis into y-axis. If a rectangle has a width of x and height y, the area of rectangle is y into x. Because it's a default shape. You just multiply the two coordinate system. You will get the area. What is the length of the circumference of that rectangle? X into y. X plus y plus x plus y. The way it is. The way you are saying, can you tell me the radius, the area of a circle in that fashion? The way you are saying, yes, I can say. See, this is radius. Radius is like this, and this is circle. It is making perpendicular with the arc, with the parameter. They are at 90 degree, and this is the de facto shape of the polar coordinate system. That is the circle. If de facto shape, then if you multiply this with the arc, you will get the area. Yes, you will get the area. What is the arc? Arc is this. If this is theta, then arc is r into theta. This is the arc. Okay. Then what is the area? Area is r into the another. If this is x-axis, then this is y-axis. As a polar coordinate system, any coordinate system has two sides. If it is talking about the area, one side is radius and another side is arc. It is something like I say this is x-axis and this is y-axis. X-axis is r theta and y-axis is r. If I think in that manner, then the circle will become a rectangle where we have one variation in r theta where r is constant, theta is variable, and another variable is r where r is variable. If I draw the circle in r theta where they are perpendicular, this is theta r theta where r is constant, theta is variable, and this is r. This is not mentioned in any of the book, and this is r. If I redraw this circle in this axis, it will make a rectangle. What is the area of rectangle? R into theta r. You mean theta r square? Yes. What is theta? Theta is 0 to 2 pi. I'm sorry. Theta is 0 to 2 pi. Then it is how much it will be? 2 pi r square. This is the area. 2 is not there. That we will see. Is it not? We are very close to the area. 2 pi r square. I am saying 2 pi r square. Okay, what is the actual area? Pi r square. Okay, we are close. Means this is, if I consider this as pi r and this, sorry, theta r and this is r, de facto area I get. Okay, what is the circumference? You tell me. This is the circumference. Circumference is nothing but extension of pi r only. What is pi? What theta r only? Theta is 2 pi r. Luckily it is solved. 2 pi r. That is the circumference. Means we are more or less we are near to it. Means if I have to do any manipulation in circle, it is better to do in theta rather than doing in xy, because circle is de facto shape of the theta, where from this vector and where from this. Okay, but theta r is not the thing that we are talking about. We are talking about x and y. We are talking about x and y. This is x-axis and this is y-axis. This is x-axis and this is y-axis. And I have a circle like this, circle like this, circle like this, circle like this. I'm talking about area and circumference in xy plane. Convert into theta r plane. Because theta r in theta r, circle is a de facto side, default side. It will be easy. Okay, tell me then how to calculate area of the circle. To calculate the area of the circle, then use the vector and theta and r. Okay, how to calculate that? To calculate that, let's divide this angle into n different parts. Let's divide this angle into n different parts. If I divide this angle into n different parts, then for any ith section, I have like this. This is the arc and this is radius. This is radius vector and this is arc vector. What is your arc vector? Arc vector, if I talk about the arc vector, then this is theta into r. If this is delta theta, then is it delta theta into r is the length of this curve. Theta into delta r. What is length of this? This is r. Then r, this is r vector. Okay. What r vector. This is the, if I talk in vector, then this is r vector that is going in this direction, and this is called theta r vector going along the circular manner. If I do cross product of this r vector and theta r vector, I'll get the area of the ith section. Okay, there are many way to do so. Many way to do so to calculate the actually cross product of these two vectors. Okay, how to calculate cross product of these two vectors? Okay, one concept of calculating the area is doing the cross product of these two vectors. Another concept is breaking into n part. That I have done. I have broken the theta that is going 0 to 2 pi into n part. This is the ith part. Then break the radius also into n part. Break the radius into n part. If we break the radius into n part, consider this is jth part. Now this is the ith jth section. Now I have divided the full circle into n part, where this is the ith part in the angle and this is the jth part in the radius. This is the ith jth part. If I add all ith jth part, summation I equal to 1 to n, summation j equal to 1 to n or m, whatever it is, and then area of one substance. What is area of this? Area of this is this, that is delta r. Delta r multiplied with the delta r is perpendicular to this line. Delta r is perpendicular to this line. Delta r multiplied with the this is r, this is r, if this is r, this is delta r, this is r delta theta, delta r into r delta theta. If I talk in vector, then this delta r is along the r direction. Delta r unit vector. Cross product with this vector. This vector. What is this vector? What is this vector? If I say this vector is r delta theta, theta unit vector, because it is going along the theta unit. R delta theta, theta unit vector. If I do cross product, I'll get the area of this section. Right? R delta r unit vector. Cross product r delta theta, theta unit vector. If someone does the cross product, it becomes r delta theta. Okay, this area is r delta r. This is delta r delta theta. Summation I equal to 1 to n, summation j equal to 1 to n. R delta r jth section, delta theta ith section. If someone makes n tends to infinity and this side n tends to infinity, then this will become infinity. Then r delta r of jth section, delta theta I of the ith section. It will come into integral calculus where r is function over theta and r, and delta theta delta r, it will become r d theta dr, r square by 2. Okay, then it will be pi r square by, it will become r square, r dr d theta, r square by 2, a square by 2 into 2 pi r square. Pi a square is the full area. Okay, what we did, not to compute accurately, we divide problem into n part and n part, and then we use vector. Means the concept is that we use parameterization so that it will be no homogeneous shape. If I have a circle, then I thought about another parameterization of a vector. If I have any vector as xi plus yj that is transformed into theta and r, then I break into n by n part. Means then if someone comes to a real track, if I have to travel 2000 kilometers, then I will take aeroplane or railway. I cannot walk it. First you take the track, on which track you have to move. I have to do parameterization here because the actual shape is circle. Theta and r, they best fit into circle. I'll change xy concept into theta and r. Then I go with a technology called dividing into n part and use vector. Okay, we will talk more on it. Means why we go for the parameterization that we are talking and dividing into n and n part, and then we will do more on it. What we will do more on it? We will proceed more in the vector and those kind of concepts. Actually, the discussion started with how we calculate the circumference of the circle. To calculate the circumference of circle, first we shifted into theta r plane. If I shift into theta r plane to calculate the circumference of the circle, I have to find this curve. I have to find this curve equation into the vector, this curve equation into vector representation. Okay, I can define a curve into vector. It is possible. I can define any straight line into vector. It is very easy. Take any 2 point along the straight line and then you can subtract it and it become a vector. If I am passing a line through point x1, y1 and x2, y2, the vector representation is x2 minus x1 plus y2 minus y1j. That is the vector representation of it. Simple. Can I represent a curved line that is passing a point x1, y1 and x2, y2? No, it cannot be x2 minus x1I plus y2 minus y1j. Not possible. If I have a straight line that is passing through a point x1, y1 and x2, y2, vector representation is x2 minus x1I plus y2 minus y1j. But if I have a curved line that is passing a point x1, y1 and x2, y2, then vector representation, this will be the vector representation, x2 minus x1I plus y2 minus y1j. But I want vector representation of this curved line. If I find vector representation of this curved line somehow, then if I calculate the magnitude of that vector, immediately I get the length by miracle. Okay, if if I have a vector representation of this curved line, if I do cross product of this vector with any another vector, I'll get the area in between. If this is the vector, one vector, and this is another vector, if I do cross product of this curve vector and this, I get the area underneath it. That is what do you mean? If I'm saying if I get vector representation of this curve line, and if I do cross product with the x axis vector, that is I vector, this is I vector, and this vector, then I'll get the area under certain. You will get area under. This is the importance of curve. But what is the representation of this? That we don't know. Okay, then we will do everything through the polar coordinate system. Can I describe? Can I describe this curve as a vector in polar coordinate system? If I describe that, then this curve, polar coordinate system means curve and radius. Curve and radius. Cartesian coordinate system means x-axis and y-axis, not the curve. X-axis and y-axis. If I talk about this curve, then this is x and this is y. If I talk about this curve, in polar coordinate system, this is the representation of angle and this is the radius. So concept is coming that how to find anything through the polar coordinate system, then intermixing, that is called hybrid. Many things we are talking here. One is parameterization, delegating x and y to r theta plane. That is one thing. Second thing, we are talking about using the vector. So vector is parameterization. Then we chop it into n part. That we saw how easily we calculated the area of the circuit, dividing into n different parts. Third thing we are coming is called hybrid model, hybrid vector model. Hybrid vector model means to solve any problem, can I use polar coordinate system and Cartesian coordinate system together? Polar coordinate system and Cartesian coordinate system together. Okay, there are many concepts here. One concept is if I have a point P here and that connects the origin. If I have a point P here and that connects the origin, then this point P can be xi plus yj, or point P can be r comma theta r, where r is the radius and theta r is like this in polar coordinate system, or xi plus yj. If I say P is a position vector, then derivative of P is the line vector that we have seen. This is valid for any of the curve. If I have any curve, if this is the curve that is if this is x-axis, then this curve is y equal to x square. Okay, this is a parabola, y equal to x square. Same thing. This is y equal to x square on both negative and positive side of the x-axis. Y equal to x square. Okay, this is y equal to square root of a square minus x square, depend upon the formula. But if I have a position vector at any point P, xi plus yj, if I calculate derivative of this position vector, d of position vector, it will result into another vector that will be tangent at that point. Luckily, in circle, tangent is perpendicular to the position vector, only in circle, not in parabola. If I have a parabola, and this is the origin, and this is point P, This is origin and this is point P. It is a parabola. Then if I connect these 2 points, then this is the line. I'm sorry. If this is parabola, if this is the origin and this is point x comma y. This is the position vector. If I calculate derivative of position vector, that at this point, then there will be another vector that will be tangent at this point, tangent vector at this point, but they are not perpendicular to each other, not required. But if it is a circle, luckily it is perpendicular to each other. Luckily, okay, in circle, if I have a point P here and if I have a position vector, derivative of position vector which is tangent vector at a particular point, if they are perpendicular to each other. If that is the concept, then I know that someone can then I know that then I know the length vector. I know the vector representation of this curve. What is that? Derivative of position vector. What is position vector? Xi plus yj, d of xi plus yj, that is dxi plus dyj is the vector that represents the curve vector, curve line. What about the polar coordinate system? D of r unit vector plus theta r, theta unit vector. That will become dr, r unit vector. Like dxi unit vector we said, right? Dr, r unit vector plus r d theta, theta unit vector. This is called length vector. Someone can take out d theta. Someone can take out d theta. It becomes dr by d theta r unit vector plus r theta unit vector bracket close into d theta. This we have named it as a length vector. Length vector can be brought through other way also. But this is the basic concept of a vector that represents a curve. Vector that represents a curve. Okay, then what is the circumference of the circle? If I talk about, if I divide this angle into n different parts, or if I cut this circumference into n different parts in polar coordinate system, this is the ith part, this is the first part, this is the ith part. If this is the ith part, then this is like this. This is the delta theta I, this is the angle theta. This is the arc. What is the vector representation of arc? D of P, that is dr r unit vector plus r d theta theta unit vector. That is the vector representation of this arc. How to find the length of this arc? If I know the length of this arc for any ith section, I'll sum it for full. I'll get the full length. That is the concept. Okay, what is the length? What is the length of this? Okay, what is length of this? This is d of p, but people they find d of p. This vector, the arc vector is d of p. D of p. If I calculate magnitude of the d of p, where p belongs to the magnitude of d of p, if d of p where one point is this of this vector and another point of this vector is this. If I calculate magnitude of this vector, I'll get the length of this section. Summation I equal to 1 to n. Summation sin I equal to 1 to n. D of p, d of p of the ith section is magnitude. If I sum for all, I get the circumference. But how to calculate d of p? D of p means what? D of p means d of r unit vector plus r theta theta unit vector in polar coordinate system, or d of xi plus yj. One is dxi plus dyj. But what is this? Dr r unit vector plus r d theta theta unit. But I have two things there, dr and d theta. It should be in one only, because at the end it is a line. Okay, but whatever we said, it is perfect. Summation I equal to 1 to n, and then d of p of the ith section its magnitude. But d of p, how I can proceed further? To calculate d of p, I can say d of p by d theta into d theta. D of p by d theta into d theta. As per any, I can multiply by same thing, divide by same thing. Okay, this now we are coming to hybrid model. D of p dp by d theta. If I differentiate position vector with d theta and calculate its magnitude, and whatever it comes as a function of theta, if I integrate with the d theta from lower limit to higher limit, then I get the circumference. But p can be anything. I can say d of xi plus yj by d theta into d theta. It is also good. Or d of r unit vector plus r theta unit vector by dx into dx. Anything I can say. because main thing is D of P. That we will proceed in the, many times I'm saying I'll proceed. Here, we will proceed in the hybrid model that, okay, I believe I have shown it dp by d theta into d theta. It works. What about dp by dx where p is in Cartesian, is in polar coordinates? D of r unit vector plus r theta theta unit vector by d theta into d theta. Okay, if I want in this manner, if I want in this manner, is it really possible? I'm sorry. D of p by dx into dx. Okay, d of p summation I equal to 1 to n. D of p by dx belonging to ith section, its magnitude into dx, that is delta xi. Okay, if I have a ith section circumference, if I have a ith section, if I have a hop, 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 if I have a ith section circumference, then this is delta x and this is delta y. Okay, dp by delta x I magnitude into delta xi. If delta xi tends to 0, dp by dx, where p is in polar coordinate system, d of r unit vector plus r theta theta unit vector by dx into, will it really give the circumference? Or dp by d theta into d theta, where p is xi plus yj by d theta, that we have seen it gives. If someone substitute x with r cos theta and y with r sin theta, of r cos theta I plus r sin theta j by d theta, it gives the circumference. What about d of r unit vector plus r theta theta unit vector by dx into dx? If it happens, then it will solve our concept that indeed polar coordinate system inside Cartesian coordinate system, any point is any point here is represented through r comma r theta, not r comma theta. The way we think, polar coordinate system is r comma theta, Cartesian coordinate system is x comma y. But polar coordinate system separately, where this is theta plane, this is theta axis, and this is r axis. If this is theta axis, this is r axis. If that is the case, then any point is r comma theta. But if we inside Cartesian coordinate system, then polar coordinate system is one is r, then another is theta r, not r. Okay, because every point should have length. R is the length of the radius, then theta r is the length of the arc. So that we will see that dp by d theta into d theta, where p is in x and y, that we have seen it works. Dp by d theta into d theta, where p is in theta r, that works. That also we have seen. Dp by dx into dx, where p is in r and theta. Okay, how it works if the theta we represent into r theta, that we will see. Okay, but I believe that it would be now a concept that it would be hitting everyone's mind, that how to imagine a r theta into x and y. A circle will behave like a rectangle. If one axis I take r theta and one axis I take as r, it will exactly behave like a rectangle. Someone would say, but it couldn't find the area. It becomes, if area becomes 2 pi r square, then consider x-axis as r theta by 2. What we can say? But circumference came correct. Anyway, what are the inside analogy? More we will talk about it. Please do not mind supporting us. As always, I have mentioned whatever we are talking here, all are concept of research only. Plus 91 is the India country code, 9483160610 is the telephone number. Plus 91 is India country code, 9483160610 telephone number. Certainly we are going to get very big thing.